Hey guys, welcome to another one of our sessions on how to create your own strategy using Breeze. In this session, we will be covering on how to, you know, uh, clone our GitHub repo, which went live really recently. So we now have the ICICI official Git repo for Python SDK only. Soon we will be coming up with a lot many other languages SDKs in GitHub like C Sharp, JavaScript, Java. Also, in this video, I'll be showing you how to create a live strategy using the functions in Python and also a flavor of the backtesting. So before you create a strategy, it's often recommended that you backtest your own strategies. So let's get started. So before deep diving into the actual coding part, let me just show you a few of the important links that I've shown on this page. So the first one is the GitHub link. So if I'll click on this, we'll be redirected to ICICI's official page for GitHub. So this has, the standard source code for Breeze Connect. If I open this, so this is a Python file. I'm sure many of you would have already cloned a lot of GitHub files in your college, in your professional environment, and things like that. So you can look over the source code here, and you can easily customize this if you're looking to prepare your own libraries, your own functions, things like that. Now, if I go on to the README section, we have a table of content in which we have, this is the about section, which will redirect you to what Breeze API is. This is the official Python client library, and it has really cool features like so and so forth. Very recently, we came up with the 1 second back data as well. And in this video, I'll show you how to download that as well. We have streaming live candles also, which is a really cool feature. So if you're looking to get live feeds, but not the tick by tick data, 1 second data, 1 minute, 5 minute, or more intervals, you can directly use this new server WebSocket, which is also a recent addition. Then we have some of the unique features like the option chain API and portfolio management APIs, which you'll find in very few places in the market. Okay, let me just go back to the table content. Okay, we have the API documentation. I'm sure many of you would have already gone through our documentation page. You can simply copy paste the code from here and get started. So if you'll notice, we have two new things. One is the historical charts v2, which is basically the version 2 of historical data. And it's different from the original historical charts, which is also there. It's different in the sense that if you'll notice, it has the second interval as well. So you can run this query for 1 second data as well. Also, a recent addition into the documentation page is the streaming live candles. You can read about the streaming live candles on this page and also copy this code and run it in your development environment. You can use VS Code, Jupyter Notebook, PyCharm, or whatever you guys are using, and just copy paste this to get started with that. Excuse me. So let's get started with this. Let me just quickly go over the GitHub repo again, just to see if I have not missed anything. Yeah, for those of you who have still not really gotten started with the Breeze API, I suggest you read about the installing client portion, how you can install our latest library, and get started with the API usage. Obviously, you can refer to this video or our previous videos on to see on how you can create your apps, generate your API keys, which is really the mandatory portion if you want to consume and get the data and everything. I might have a link to our previous videos as well. So if you will go to this link, you can see these are some of the Breeze videos that we have in which we have, really answered one of the most frequent questions and how you can, place orders, get data, things like that. So this is a really cool thing. Also, I will upload this Python file on the GitHub as well, so that you can refer back to these links whenever you want. And if you want to see where the SDK methods are, I think you'll find a list of all the API functions there. And if you click on anything, let's say place order, you will be directed to a readily copyable code, which you can, just paste it in your platform. All right. So far, so good. So before we get started, I need to get my app keys. I need to log in into my account and get my API keys that we can get started. But the good thing is I already might have these things ready with me. So I'm sure we can use this. All right. So the first portion would be to initialize your keys. If people are confused over where to get these keys from, I'm sure there are other videos in which you explain. It's basically this login page. You just have to log in your user ID and password and then register an app. And that's it. You are good to go. So since I've already generated my app and API keys, I'll not be logging in again. This session would mostly be covering the strategy piece of it. So let's get that. All right. Okay. All right. So I have 3 API keys. We have API key, API secret key, and session keys. So these are 3 keys which are really required to get started with Breeze. The next thing would be to generate a session. Just right here, generate a session. All right. So let me just go to the GitHub and copy the starting content. Let's go to the API usage portion. All right, I've just copied this. I am on my Jupyter notebook again. So yeah, if somebody's wondering which development environment I use, it's Anaconda. It's one of the world's most popular data science platform. Obviously, there are other platforms as well, like Visual Studio and PyCharm and Spider. So feel free to use any one of those. The code should work fine in everything. So right, I just pasted the code course piece, which I downloaded from GitHub. So the first line is really about importing the Breeze library. So one thing to note here, if any of you guys is doing this for the first time, I suggest you install Breeze library once so that the library is in your portion. And, all right, if I just go on top, yeah, installing the client, there you can see you need to upgrade your Breeze Connect libraries to use the latest functions. Let me just copy that. And if you want, you can also go to our PyP page. This is the latest version which is running. You can just click on this and it will copy this. And you can put it inside your terminal or your development environment. So let me just paste that. So upgrade is just a cool feature that pip has. It's basically upgrading the already installed library. So I'll just run this. The star represents that it's running, right? Okay, the requirement is already satisfied, which means the library has already been upgraded and I don't need this anymore. I'll just comment it out. All right, so this line basically says that I'm importing the library. Sure, most of you already know. This is initializing the SDK. Okay, and let me just go over we have here. This is not required. I don't need to. This is for logging in. Okay, I'll just show you what this does. I'll just copy this. So I've copied this and pasted it right here. Okay, so let me just run this piece first. Okay, so Jupyter has this really cool feature that you can run codes in blocks. So I'll just be running these 2 lines only. So if I do this, it's processing. Okay, it has completed without throwing an error. So I believe we're good to go. Okay, let me remove this and show you what these two lines mean. So it is saying that it will print the login URL in which you can get your session key, which is your third key. Since I already have generated it, I don't need this. Still, I'll show you how you can do this. So it's essentially asking you to paste your API key here. Since I've already stored that in a variable API key, I'll just paste this. Okay, so if I have run, when I run this, it gives me a link to the login portion where if you pass in your user ID details, you will get the session token, right? Okay, right. So I don't need this, so I'll just remove this. Okay, so the next two piece has basically generate the session and generate a time string. We're not concerned with the time string here, so I'll just remove this. This is the only line that we need. So this is a function which generates your session. This is basically what you use to go live with your DMAT account. Let me just put my secret key here. I think I've named it API secret. Yes, it is API secret. And then it's API session. Okay. So this is running and it is successful. Okay. Before we begin, let's see if I am able to run any API because my connection is there, right? So, okay, let me just pick any of the APIs from here, the GitHub. All right, let's see the historical data, okay? Just copy this, go back to my screen, run this, and voila, I am getting a lot of data, which means that my API is successful, okay? Let me just remove this. So now I think we can get started with the strategy. Okay, now that the session is live, what I need to do is I need to download some data, right? Okay, so this is, I just pasted the function for the historical data API, okay? Just copy this from the GitHub, okay? So if you notice, when I run this, I get the response in form of what we call a dictionary, okay? This is a dictionary, you see the curly brackets here. So what we'll do is we'll try to convert this into a good format first, okay? So let me store this in a variable data. So if I print data, this is there, right? It does not look very fancy. If you notice, the data is basically inside the success key of this dictionary. So what I do is I do this, and okay, right. All right. Data 2 is basically data success, and let me convert it into a data frame from pandas. So this is why we use Python, right? It offers you a lot of cool features. And right. So I've just run this, and pandas is a library given you by Python. It helps in storing data in a database. All right. So I have ICICI Bank stock code, I have volume, OHLCV, and things like that. All right. So okay, so far so good. Let me just change the variables. Let me download it, not for futures. Let's say you'd want to download a data for a stock. Let me use ITC. The exchange code will become NSE. Since I want to download the equity, I will do cash. I don't need the expiry date, right, or strike price, right? In stocks, these entities are invalid, so I'll just remove these. And okay, so today is 7th of December. So let me download data till yesterday, 6th December, right? And I want to download it for, let's say, the past year. So let me give this 01, 01. This essentially is the hour, minute, and second Since I'm downloading the data for one day, I'm not really concerned with these things, right? Okay, so let's see. Okay, I've run both these things and I've got ITC data, open, high, low, close, the time, the exchange code, and it's like that. Okay, I don't need the exchange code and volume. I just need the closing price. So let's see how we do that. Okay, let me just clear the output. All right, so I have the data in data too, right? So let me do something like this. Okay, I don't know which columns are there in data 2. Okay, so these are the columns in data 2. I just need the close price and the date time price. And okay, open, high, low, close as well. So let me just copy it from here and paste it here. We can remove the exchange code, right? And this looks good. Okay, I think we have missed a bracket here. Right, so there are two square brackets, right? Getting an error, date time, okay. Let me just remove. Let's just try to get the close price first. Let's see. No, I think we have, yes, okay. So the data 2 variable shouldn't be here. So I believe that was the issue. Let me just copy the other variables again. So the reason why we're doing this is we don't want to store too much data in a data frame, right? So I'll just remove this and okay, let's run these three queries again. All right, now let's see what we have in data 2. Right, we have the date time, we have the OHLC values. Okay, so the reason why we are storing this in a data frame, because the data frame panels data frame lets us do a lot of cool stuff. So let's say you want to see the mean price of the closing data, right? So we can simply do this data to close dot mean. So if I do, okay, so we've got an error, which is saying we could not convert string to float. So another thing which brings me to this is if you look at closely at this data 2, you will notice that these look like numbers, but what they are essentially are, these are a string value. Let me show you. So if I do something like this, okay, so the type variable basically shows what is the data type of the variable. And inside this, I have given this, which if I print is basically one value, right? So what data close I location one is, it's basically the first location. This is the 0 location index. This is the first location and close variable, this value. So this is data close ilog one. And if I have seen the type of this, it is string, and you cannot calculate the mean of a string. So what we'll have to do is we'll have to convert this value into a float. How do we do that? Okay, so let's remove this. What I need to do is this is function as type. This is type conversion of the series. I'll just write it float, which corresponds to a double value in Java, or let's say an integer value, right? And I'll have to say put it equal. Does not have an attribute. Okay, I think I've messed up the syntax. Okay, so yeah, this is data 2, right? This is not data. Okay, data 2. Right. So if I do run this function again, right, which used to give me an error. Now we have the mean value, right? All right. So I need to convert the high-low open into the float also. So what I'll do is, right, open, high, and low, right? I think this should complete it. Okay. Now, if you look at data two now, doesn't change the look and appearance, but since we have changed the type conversion of all these variables into float, now we can, do a lot of things in there. All right, so far so good. Obviously, there are much quicker ways of doing all this, but I'll show you how to make the code a lot better and quicker as well. Okay, so now what we want to do is, let's say we want to calculate SMA, right? And our strategy would be if the current price is greater than SMA, then buy. Okay. So since this is only a demo piece, we focus more on the how the execution piece of the strategy would look like. And once we complete that, we can obviously recalculate and fine tune our strategy. We can calculate a lot more indicators, so on and so forth. Okay. So before we calculate the SMA, we need to specify how many days of SMA do we need, right? So let's start with 14-day SMA. Okay. Let's download data for 14 days only. Okay. So we are standing on 6th December today. I think it's 7th December. Sorry. Nice. Okay. Yeah, we're downloading data yesterday and 14 days behind that. Let's calculate from 20th November. Okay. So, right, from 21st November, I have roughly 11 trading days. So we have values for 11. Okay. Oh, that's nice. Let me just combine all these data cells so that I can run them at one go. Let me just increase it to 15 so that at least I have 14 days of data, right? Okay, I have 15 days of data, which is okay for demo reasons. Right, so let me say SMA is data2.close.main, right? And let me just print this. So we have 340 value. All right. The next question is, how do we get the current price? Okay. All right. We'll use an API for this as well. So let me go back to the GitHub repo. Okay. Let's see, how can I get the latest code? I think we have get codes here. Okay, let me just copy this and paste it here. Now we're dealing with ITC here, so let me just change the parameters again. There is no concept of expiry date. Product type is cash. I don't need write or strike, so we can remove this. And let's store this data in, let's say, price. Okay, this has successfully run. So let's see what is inside price. Okay, so it has given me the last traded time and the last traded price of ITC. It has a lot of details as well. What is the price in Bombay Stock Exchange, NSE, so on and so forth. Lots of data. But I don't need so much data. I just need last traded price, right? Okay, so how do I get that? So first we access the success key, right? And right, since inside the success key is a list which has two dictionaries, right? The square bracket. To know more about data structures of Python, I suggest you go to the Python documentation. They have a really nice documentation of this. So I will need to access the first element, the NSE. I'm more interested with the NSE price. So I will give 0, which is the index of the first element. And inside that, I need the LTP. All right, the LTP. All right, 340.1. Now remember, I have to convert everything to float. Okay, which is nice. I already have this in float, so I don't need to do any type conversion for this. Okay, so let me store this in a variable current price, right? Okay, so now if I print current price, I have this, right? Okay, so my condition would look something like if my current price is greater than SMA. Did I store mean in some value? Yeah, I stored it in a variable called SMA, right? It's greater than SMA. For now, I'm just checking. Print yes. It has not printed anything, so it means it's just lesser, right? Okay, so what I want to do is, as the market is moving, I want to keep checking this condition time and again, right? And I want to keep on doing this unless it prints yes and I do a buy order. So let me write a code for this. Okay. So first thing is we need to import some libraries to import date time. Specify even a start date. Let's say what is the time today? It's 7 December 4:28 p.m. right? So this is year, and the month is December. It's 7 today. It does not accept 0, which is okay. It is 28 now, and all right. Let's see. So what I've done is I have given the current time in a variable called start time. Similarly, I'll create a variable called end time. Let's keep it to 30. What I'm trying to do here is I want my strategy to only be active between start time and end time. I don't want it to run it for the whole day or whole month or whole year. So, this is what traders usually deploy in their strategies. I'll just write the clock here just so that we know what we're doing, right? So we want to activate the clock, and only when I'm between this time interval, I want this condition to keep on checking, and that is the time in which my strategy will be live, right? So clock for live strategy, I'll just write this. Okay, so I need to create another variable now, which is basically what the time is currently. So I'll use something like this. If I print now, you will see that I'm getting 2022, 12 December, 7 December, 16, 29, 43 seconds, and it even gives microseconds. So, this is more helpful for people who are doing high frequency trading and things like that. All right, let's go on. So I'll write some condition like while my current time is greater than my start time, and my current time is less than my end time, only then do I want to do something, right? So we already have this condition, right? Just use this right here. So what I'm doing is inside this while loop is between this time interval, start and end, I am checking the current price and the SMA price, right? But what you will notice is that even if it runs a lot many times, the current price remains the same. So this basically, I'm checking the same condition again. So I need to update my current price as my loop keeps on moving. So what I'll do is I'll call the API again. So this is the API, right? Let me just merge these cells. So if you'll notice, my code is becoming cleaner as we are discussing, and it's getting reconciled quite nicely. All right. We can even remove this variable price also. But okay, let's keep it. We'll focus on reformatting things again, right? Now, a lot many times it might be the case that you are fetching your price, right? The current price, you're storing it in this variable, the NSE price, and you are going to the second iteration of the loop. But it's the nature of HTTP request or the REST API that this request will take a few milliseconds of time. What I don't want to do is I want to process so many requests in a very short time, which can crash the server as well. So I'll just introduce a time sleep, which basically pauses my entire program for whatever number I give. So this means program will be paused for 123 seconds. That's a lot, right? Let me just pause it for 3 seconds. Okay, and before that, I'll just have to import the time library as well. All right. Okay. One more check, which I want to show you guys. It's sort of a sanity check, but you should use this is when I run this API and I print this, you can see I am getting a status as well. So in HTTP protocol, which is the internet protocol, a status of 200 means that the request was successful. If you would have got a status of 500, it would mean that the success wasn't really there. It was a failed request. So what we usually do is we check that its status is 200. So if I use something like if price status is 200, print request was a success. Okay, I think you'll have to put this in. Okay, I think this is capital S. Well, let's just print this again and see if we're doing the right thing. See, it is taking some time. I'll just run this again. Okay. So yeah, I guess right. It is status with a capital S. So yes. Okay. So the error we're getting on this equal to, this is basically equal to the assigning operator. We need to use a double equal to. Yeah, right. The request was, sorry guys, my bad. But all right, let's use this in our main logic as well, because only if the request was success do we want to proceed ahead, right? So instead of printing that the request was a success, okay, let's print that as well. And then let's store the current price here. And if this, I need to give an else condition also. I'll just write failed request so that we know that our API call did not happen, right? Okay. Last thing that you want to do is update the now variable as well. So if you notice, this condition is also static, means it is not changing. The start time and the end time are fixed, but the now is not changing. So what we need to do is just clear all the outputs. I need to calculate the now also again. I'll just remove these variables so that the code looks clean. Right, this should be inside the loop. So before I exit, I will calculate the time. Okay, this should be after this. Right. So let's see. First of all, let me see what the time is right now. Okay. Let me paste it here. Right. And let's just run this. So currently it is 16:36:17. So let me start my algo between from 37 to 38, right? I think this is all correct. Let's run this. Okay, I've got some error. Okay. I think it was a double and. Okay, no, sorry. I think this is the operator is and. Yes, this has run, but if you'll see, nothing has happened really. The reason why is my current time is 4:36, but I'm starting my algo from 4:37. That's why nothing is getting printed, right? Neither yes, neither no. Let me print it no. So let's see. The time is 16:37 now. So if I run this now, okay, we've got no, and we're getting the response in 3 seconds after a gap of 3 seconds, right? So what essentially is happening is it's printing no, which is the output of these condition, and it is printing one of these statements that either request was a success or request was a failed request basis these conditions. It's printing no, which means that basically current price is less. Okay. And I say buy signal. Let me say do nothing. Okay. All right. So I'm just restarting this thing. See what will happen now. And one more thing to make the code even neater is let's print this current price. So what I will do is I'll calculate the current price and find that request was a success, and request was success. Current ITC price is this. Okay. All right. One thing that is clearly very obvious is that current price won't change even after we making repeated API calls is the market is closed, right? It won't change. This will work. This strategy will actually work when the market is live. But anyhow, we'll cover that piece as well. But so far, so good. Let's see what the time is. It's 16:39 right now. So let me try to run between 40 and 41. Okay. So nothing has happened. And I'll just wait for the time to hit 40, or we can do this as well. 39 50 seconds. We can specify this. Right. So I've run this and I'm getting the current price is less than SMA, do nothing. Request was a success and current ITC price is 341. Okay, so this will keep on happening after every 3 seconds, right? So what you can do to fine tune this is number one, you can set the start time as per your wish, right? Right. And similarly, you can design the end time also, whatever you want, right? And if you would run this during market hours, I can assure you that you will get different prices in these columns, because after every 3 seconds, the price would change. Now, I don't want to, whenever the buy signal is generated, I just don't want to print anything. I want to actually buy an ITC order. How do I do that? So let me give a variable y and run the API for buy order. Let me go back to the GitHub and see how to place an order. If I'm here, let me just copy here. So this is placing a futures order from your account. This is an option order. This is okay. I have the cash order as well. So let me just copy this. I have ITC as an example as well. Fantastic. So let me just go there and paste this. So if you look at the parameters that we're sending a limit order of 305 price. Now, if you want to send a limit order at whatever the current price was, you can even do this. You can just copy this and you can paste this, but since it accepts in a string format, you should do this. So this will place a buy order of ITC, a limit order of ITC in NSE on delivery basis at the current price. And whatever the response from the exchange is, whether your order is accepted, rejected, or if your margin is less or whatever, that will be stored in buy variable, right? Okay. And if the signal is not reached, we don't want to buy anything. So there is no need for additional coding in this. We can simply print that the current price is less than SMA. So just do nothing. All right. So far, so good. Let me fine tune it even more. What I want to do is I want to run my strategy on a daily basis, right? For that, what I will need to do is I have to calculate all these things every day. Okay. So I want my from date and to date to be also dynamic. So what I should do is I should do something like date time dot today. So this prints basically today's date time. You should give in to date this today, right? I don't think this will work right now because as per the API documentation, only ISO format dates are accepted. So you'll have to do a type conversion again. You'll have to convert it into a ISO date time format. I don't want to get into how to do all this conversion. I should remember I just deleted that portion of API usage. I think that talks about that. Right. Here is how you can generate dates and convert them and things like that. Right. I think, yeah, this was it. So that is one way to fine tune your data and do this exercise on a daily basis. From date, you can do something like from date is equal to today minus time delta. Then this is the function. Days is equal to 20. Let's see if it works. Time delta not found. Okay, I'll have to import that library from date time, import time delta. Right. So now if I run this, I'm getting 17th November as 20 days behind today's date. Okay. So you can do this, and instead of from date and to date today, you can do this. Obviously, you'll have to convert both these dates into ISO datetime format first. And I think if you run this code on a daily basis, what it will do is it will back calculate the SMA, 14-day SMA or 20-day or whichever number you have put here, and it will calculate its mean. And then based on the design of your clock, it will check after every 3 seconds what the current price of ITC is. And basis that, it will either buy it or it will do nothing. So yeah, so this is simply a very basic template of how you can create live strategies in Breeze. Okay. I think I have already a clean file for this, I believe. Okay. So this was something which I've already created and done. So we will be uploading this strategy in a more cleaner way so that you can see it for yourself. Now, before I wrap this session, there are a few things that I would like to talk about. One is backtesting. So before you go all excited with these live strategies, a word of caution here: these are not recommended strategies. You'll have to sit and figure out very many permutation combinations with different stocks, indexes, or even option strategies. Right? You should do that before you go live with any strategy. So for all that purpose, we have something called backtesting, where you should backtest your strategy and see if the signals that are getting generated are actually proper or not. So I'll just show you how you can do that very quickly. So let me just copy this, go down and say, okay, all right. So this is bad, right? From date should be something different. So let me just go back to Python and select a good date. So the date which is mentioned here is basically the ISO time format. ISO time format has YMD variable, a capital T, and separated by R minute seconds. Let's use this. And let's say I'm going to calculate till 12th, calculate till 6th December, and from 1st January. Okay, so I have this data. Okay, let me create dimension variables here. All right, so let's say I have SMA data2 dot close dot rolling dot main 14. So what this function is basically doing is it is calculating rolling SMA for this variable. So I'll call this short SMA. And similarly, I can create a long SMA. Okay, no feature variable. And I think we have to convert it into okay, I think this is the variable, and also I'll have to convert these things into float. Oh no, I think I've already done it. Right. Okay, so if you look at short SMA, you'll find there are a series like this. Okay, let's say I have, or better yet, let me store this all into a data frame. What I'm trying to show you is how you can create indicators and store them in your data frame. We're calling this data2, right? So if I print data2 now, you can see I have short SMA and long SMA. The reason why I'm getting NAN is because for this day, I do not have 14 days of back data. So it is saying non-applicable. There is a way to drop these variables as well. Just drop NA, I think. Right. All right, the data looks much clean. So if you want to test out on how many days the signal of buy signal was generated one, you can do that easily, saying, let's create a condition, right? If buy signal is basically if your short SMA, let's say this is greater than close value, right? Sorry, this was this, right? Current price is greater than SMA, then there was a buy signal in our live strategy, right? All right, but to do that in a data frame, you'll have to use NumPy. I'll use where method from NumPy. or create this condition. Okay, so what this line does is it checks that for all the values where short SMA is lesser than the closing value, the signal is or create buy signal of 1, otherwise 0. Let's try to run this. Close is not defined. Okay, so this is not close, this is data2.close. Right. So if I use buy signal, I'll get an error, right? Let's store this into the data frame itself. Okay, data2. Keep messing up names, but okay. This is a warning, just a warning. This is not an error, but we can ignore that for now. Let's see. So I have a buy signal which has a lot many zeros. So there is no signal on these points. But if I try to see on, did it create any signal on any of the days? Let's see that. Yeah. So on 31st January or 1st February, 2nd February, on these days, there was a buy signal, right? Very recently, it was on 11th November. So this is these are very basic building blocks of how you can use the historical data to calculate whether or not your strategy will generate any signals, right? And you can actually see that on these days, if you would have bought, the price would have increased from 220 to 227. You would have made some profit, right? So since pandas is a really powerful data frame, you can use something like this, I think, to calculate the returns for the closing prices as well. So yeah, since we're lack on time, I'll not be touching that. I'll just try to show you some of the other cool features that we have on Breeze right now. All right. One thing before I go on is how you can quickly clone the GitHub library and see the existing strategies which are there on Breeze Python SDK. So if you look at this, we have a folder examples in which if you'll open, you'll find two sample Python files here, the SMA, RSI, and the API samples, which really talks about how you can, use this, the API, not using the SDK, but at the source code level. It also has 1-second API and how you can use that. Let me quickly show you how you can do this all. So instead of copy pasting, there is a really cool feature which Git gives. It says Git clone. You'll just have to go to any GitHub repo that you want to clone into your system. Just click on code, click on copy, and go here. Okay, so I am in my documents folder inside the demo folder. And inside the demo folder, I'm just using Git clone. I have pasted the address, the URL address of my Python SDK. If I press enter, it is just cloning the GitHub repo. So it's done, right? So if you can see, it just seconds ago, a new folder of Breeze Python SDK came. If I open this, I can see all the files which are there in the GitHub. Just open examples. I'll just open the SMA RSI example. Just copy this and let's create a new notebook. Just pasted all this. And let me paste my API secret key here. See how can I use this. So, right. The reason why it might not work is because the session token might have expired and there might be different variable names of these keys and session keys. I'll just give it one final try. If you look at here, we've mentioned secret key, but it's actually API secret in my code. Not sure. But okay, no harm in giving it a try. It's showing error, I think, at this line. Right. This is not really a comment in GitHub. Okay, I have run this, still processing. And when it is processing, it said error size not defined. I think it is, all right, it is smaller variable, right? Okay, this was successfully run. And if you will see, the output of this file is basically a data frame which has open, high, low, close, and 3 columns of indicators, the short SMA, long SMA, and the RSI. So what this code is essentially doing is it is calculating historical data in a data frame, and it is adding 3 indicators, add SMA and added RSI. Within SMA, it is adding short SMA and long SMA. If you'll go through this code, you will find a lot of similarity between what we have already covered today and what is there on this. The reason why I'm showing you this is that you know how to clone the GitHub libraries and see all these examples for yourself. All right, I think we're already at time, so let me take on a few questions if you have any. Right. Okay, I can see a lot of comments on page. Okay, so we have Tushar is asking, can we share the link of all these in the description? And can you please share how to convert the live feed in a data frame? Okay, I'll take this question first. So number one is all these important links that we have for GitHub, for login, and all the YouTube links. I'll just create a Python file and upload it on the GitHub, or right. So you can and share a link with all of you. If at all you are still stuck at how to create that, I suggest just drop me a quick mail at breezesecurities.com. Um, the address for this is this. So just drop us a mail at this if you're stuck at any point or if you don't know how to get these links. Although the GitHub link, you can pretty much Google it. It is ICICIdirect Breeze Python SDK. On our homepage, I think we have links to this as well. So Breeze Python SDK, or if you go to this, you will find the link to our PyPy page. So yeah, that is there. Again, so the link piece, don't worry about that, guys. We'll share all these links in our GitHub, in our home pages, and everywhere, and mail you thing. So that is there. But still, if you don't get it, just mail us at this ID, right? Okay. Another question is, how can I convert live feed in a data frame? Okay. Right. So let me just go to the GitHub again and go to the WebSocket usage. Okay. So this is what the participant is referring to. What they want is, let me just create a new file. This is the WebSocket, right? I'll just remove most of things here. Okay. So you would have seen a use case like this. You already know this is library setup. This is API. When you go on to this line, this basically is setting up your WebSocket connection. And this is the function where your ticks, the tick by tick data is getting printed. All you need to do is to store these is create an empty list just on top of this line, tick feed, right? Go inside this function, and doesn't matter whether you append the feeds below or above the print line, but here is what you need to do. you need to create this tick feed.append ticks. What this will do is all the ticks which are coming through the WebSockets, these will get stored in the tick feed. And later on, you can simply print or see the tick feed, which will be a list of values, and you can access any value with its index or whatever, right? You can convert them into a data frame, an array, or whatever. Okay, so this is the code, guys. This is just 2 lines. All right, let's see what else. Um, okay. Somebody saying, is there a rate limit for number of calls per second, for example, historical data? Yes, rate limits for all our APIs are currently the same, which is 100 per minute and 5,000 per day, I believe. So if you will go to this, if you go to the documentation, you can read about this here. Yes. So this is what the rate limits are. It's 100 API calls per minute and 5,000 per day. So that is there. Um, Then we have one question like, do we have APIs for technical indicators? We'll be coming up with another set of SDKs for our APIs, which will cover that piece. So yes, that will be there. There'll be a lot many technical indicators which we'll have. So yes. Then I have SMA also changes during the time. So should we reinitiate SMA variable inside the while loop? So that is also true. That is something you can obviously, as I said, refine tune these strategies. So it's a very intelligent thought. Somebody is saying that we can recalculate SMA also inside the loop. So that is true. You can actually download historical data for the last 14 minutes, right? And then do that instead of 1 day, just write 1 minute, you'll get every minute data and you can calculate SMA on a minute by minute basis. So it will be the last 14 minutes SMA, which we can get. So people are asking, where can I get this GitHub library and how can we get access to this documentation? All right, so let me just post this in the chat right now so that you all can access that. So I have posted the GitHub link in the chat, and which you can use to get access to all the other links. So I'll just finally go over the GitHub again. There we have these things, right? Inside Breeze Python client, we have the documentation link. If I just open this, this is the documentation. If I open this, this is the IP page, which you can access. We have not many other API usage link, the WebSocket link and everything. We have the examples. So today, what we have discussed, I'll just upload this strategy here as a demo strategy as a separate Python file. So you can access all of that. So I've just pasted the link to GitHub in the chat box. Check that out and let me know whatever ideas you have for our next sessions. In next session, I'll be covering more advanced strategies, how you can fine tune this, and how you can speed up the processing. Also, I will be covering how you can use WebSockets for all this. So currently in this lecture, we decided to use a while loop, but we can actually do this seamlessly using WebSockets as well. So stay tuned. Next lecture or next session, we'll try to do all of that stuff as well. Thank you guys. I think that would be all from my side. Thank you for joining in. See you next time. Bye bye.